us has heard of Salt before? Okay, that's good. We're running on about 68%. Who here has used Salt before, or at least played around with it? Oh, good land, that's lower. Who here has used or is using Salt on a regular basis? Who's actually using it on systems? Excellent. I know you are, Lexi. And I know Chris is back there. He's been doing it since, well, since before it ever even kind of worked. Okay. All right, that helps me know where I'm coming from, and also reveals that some of the content in my presentation is inappropriate for the audience. But we'll see what we can do. All right. Now, let me explain what SALT is, where it came from, kind of this overarching idea, because we're most commonly chucked inside of the configuration management basket, where you say, well, SALT's like these other guys who are configuration management tools. Hooray, we're done. The reality is that SALT is a radically different design from configuration management tools, and that the foundation of SALT and most of what I'm going to be talking to you guys about today has to do with the fact that SALT is about communication and enabling communication inside of an infrastructure. What this means at the end of the day is that you're able to run on live data, and you're able to make very dynamic decisions and do some really crazy stuff inside of SALT, and some really powerful stuff inside of SALT when it comes to managing your infrastructure. And with that said, SALT is still ridiculously easy to get up and going. It's made to be as easy as I've been able to come up with so far. We're actually working on some modes to make it easier. Now, the history of SALT, I started writing it in my basement in February of 2011. Before that, I was working on a problem that I was obsessed with, and that was the idea that I wanted to be able to query generic information from hundreds or thousands or tens of thousands of systems in parallel and get it back at ridiculous speeds, meaning in a few seconds, so I could make decisions based on what's going on in infrastructure in real time. I started working on this problem in college, and I failed, and I worked on it for the US government, and it worked a little better, but in the end I think I failed, until I figured out how to pull it off with SALT. So the core idea behind SALT is to send a command out and allow lots of systems to return in parallel information. Now, the fantastic thing that happens on top of this concept is that it facilitates a really interesting communication bus that allows you to start doing some, well, really incredible things inside of an infrastructure, which I'm going to talk about. Now, the goals of SALT are to continue being and becoming an easier to use, more powerful, faster, and more flexible management platform. SALT is run by my company, SaltStack Incorporated. We've been around for almost a year now, and we're doing well. We're funded, and we have lots of customers, and things are moving up. So we're not going anywhere. Okay. Now, the vision of SALT as infrastructure management, and beyond this core idea of high-speed communication, is this idea of state and flow. And that if you can control the state of your infrastructure that it is in, then that's one side of the coin, and the other side is controlling the manipulation and data gathering of an infrastructure. And that bringing those together enables you to do anything that you need to do, at least that's the goal, anything that you need to do to manage any type of infrastructure that you're dealing with. Okay? And what this really hinges on is this concept of being able to get live data from your infrastructure and run on it. One thing that's really cool about SALT is that it doesn't require any database backends. It doesn't require any third-party message queuing software. It doesn't require any search systems or anything of that nature. You set it up, it's all self-contained, and it goes. Okay. I know, I've said that like 8 times, that one on top. I'm sorry. I'm not the best slide maker. Now, SALT, therefore, is a communication system that abstracts lots of building blocks for creating an infrastructure. And by building blocks, I mean you've got components that you can use and insert into your infrastructure to solve your problems, because, believe it or not, other people have those problems too, and we've talked to them and given them tools to solve them. And so it's building blocks. The state and flow idea are just these core building blocks that we put more concepts on top of. The other cool thing about SALT is that you might look at it and think, well, that looks big and complicated because it does all of these crazy things, or rather has all these crazy components in it. But remember that nothing inside of SALT turns on until you start using it. So you don't have a bunch of bloated stuff happening in the background. Okay. Finally, SALT has been made from the ground up to be massively scalable. The core concepts of how SALT works, because it's all asynchronous networking, it uses internal queuing systems, it's made to be able to handle large infrastructures. And we've got large infrastructures using us. LinkedIn's infrastructure is a fantastic example, but we've got a lot of hosting providers who are using us to manage many deployments in the tens of thousands of systems. We're working with a few customers right now who are actually setting up SALT in environments with hundreds of thousands of systems. Okay, so the great thing there is that you're able to start and say, okay, I'm going to start with SALT. It's not going to be a pain to get going with. It's got a very shallow initial learning curve. You can get going quickly. But you have the assurance that it's going to hold up to the scale that you need it to. That what you're learning and what you're applying early on is going to be able to keep carrying you through the process of growing an infrastructure, which is generally what we want the companies we're building infrastructures to be doing, right? It's always better to be working for someone who needs more juice than someone who keeps needing less. Okay. So, I don't have a lot of time. Usually I pause constantly and ask for questions, but there's only like 45 minutes here. Yes?
What does SALT compete with?
SALT competes in the configuration management space with tools like Puppet and Chef. And SALT also competes in the remote execution and orchestration spaces with tools like Fabric. From a very high level, we've got guys who are using SALT to replace, well, some other kind of crazy things. I'll mention some of that. Okay. So one of the first things I want to talk about here are some of the communication topologies that exist inside of SALT that can be used to do things like build out to massive scale, work with multiple data centers, build out high availability, interface with databases and things like that before we dive into the configuration management component of SALT into a little more depth. So, the first thing that I want to talk about is this concept of data living in an infrastructure. So there's an old concept out there. Wow, that gets cut off. These say things. Okay. There's an old concept out there of a CMDB. Who in here deals with a CMDB? Wow, we're like in California. This is cool. It's not like back east. Okay. The idea of a CMDB is that there's a database somewhere that has information about your infrastructure. And most people I've talked to don't like them. And so one of the benefits of SALT is that you're able to take information about your infrastructure and let it live on your infrastructure, which makes your infrastructure kind of self-aware of what's going on. All of your servers are able to come back and instantly report and say, this is who I am, this is what I have. We can insert data directly into the servers in your infrastructure so that they can be reporting back what roles they have. They automatically detect all of their hardware specifications, et cetera, and this can be instantly reported on or targeted. Okay. So, data management is a big piece of what SALT is. Now, there's a mine there. and these actually say grains and data. How this works is that Salt has a system in it called grains. What grains do is that they're static pieces of information about the systems that you're managing. And so these grains, by default, it auto-populates with a bunch of properties about that underlying system, and they're all static properties. So it populates these static properties about your system so you don't have to run executions to requery them, and then holds on to them in the context of what we call the minion. The client in Salt is called a minion. I mean, because that's a great name. But more specifically, the reason that we call it a minion is because it's something that you give a brief command to, and then it goes out and does the work for you, which is, hopefully what a minion would be doing if you had them. Okay. So out inside of the Salt minions, it says there's grains right there, and that can be used to statically set information about the systems and categorize the systems as well, okay? And so it's going to auto-populate with what operating system it is, what operating system family it is, the CPU architecture, the Python path, how much RAM is on, all that stuff. But then you can set values in there. So you can set grains that say, this server is filling these 5 roles or these 2 roles, for instance. Yes, oh, sorry, that wasn't a hand, that was adjusting a camera. Sorry. Your hand is now invalid. Now, all right. Now the other block in there that you cannot see because of X11 says data. Salt is able to manage a number of data backends directly on the minions. So if you wanted to, we've run into a couple corporations, not a ton, but a number of corporations where they wanted to be able to store really big chunks of information out in their infrastructure about those servers, so like a warranty information or stuff like that. Basically, we got a bucket for that. Yes, your hand is valid.
You say path can change.
The Python path as it is realized by the Salt minion. Okay. Thank you. Man. Okay. Or Salt can be used to integrate with any existing CMDB or database or data whatever, or interface, okay? Inside of Salt, it's all about data management and data modeling. And so the basic architecture of Salt is that you've got a master server out here, and it's got its minions that are doing its bidding. And that master is holding all of the data relative to how those minions should behave, okay? Now, since it boils down to just data, we don't care where that data comes from. And so let me make it a little more succinct from a perspective of configuration management. Salt's configuration management system is entirely data-driven, and all data inside of Salt ends up being reduced to JSON serializable objects, which is basically dictionaries. It's a Python group. I can just say dictionaries. I don't have to say, or hash maps. Okay? They're basically dictionaries, lists, strings, integers, booleans, right? Okay. That means that it's extremely easy to make this data malleable. So I'm going to run some commands on a command line and keep it on the top of the screen. I'll be pushing Control L a lot. That's how you do that. But all of this information that's coming through Salt is always simplified, again, down to these simple data structures. Again, very malleable. And so that means that we can generate information in a system called Pillar on the master and have it go and query and gather information from any arbitrary external tool and just shove it right into the workflow. Now, this is really cool because you go into a big organization and they've almost always got some database with information about their systems. They can just drop a Python file in, and if we've got time, I'll show you some of these. Well, we'll definitely have time afterwards regardless, but But if we've got time, I'll show you these Python files, and you plop a Python file in. To write these, you don't need to know anything about the internals of Salt. You don't even need to have to inherit some class inside of Salt. You just write a function and it works. Okay? And then it's able to bring data in from an external source and make it available. Down here, there's some minions. Sorry, you'll have to trust me. I will make these slides available, of course.
Just pop it out of presentation mode.
Well, see. I've just been trumped intellectually. Okay. All right. That is the bottom of this one. Okay. So here's another concept that we have inside of SALT. And this is the peer idea. Now, again, I already apologize for some of the audience-based concepts here. So the core concept in SALT is, again, you've got a master, it's got minions, and the master sends a command in parallel out to those guys, and then, well, out to targeted guys, and you can target based on anything you can dream of, really. Sends it out, they execute on it, and then return, and it's all asynchronous, which is quite nifty because the master sends a command out, it lets go of all the connections, otherwise we can't keep up performance-wise, and then it just waits for these guys who return the messages and the messages are all tagged with the job ID, so the master is able to categorize them properly, okay? And they're audited and all that jazz, so you know who did what, you know who to shoot if they ran the wrong command. Now, another one of the concepts that we've got is that obviously the master is where we're originating data from, or originating commands from. And that means that the master is the system that is able to go out and query data or send command data. And these commands that it sends out is a really vast library of routines that are all these system management routines that are built into SALT. And so, you've got access to do all these things and get information back. You can get arbitrary information back about pretty much anything that you want. Now, a really good example, I was talking to some guys over here, and I mentioned what some dudes in Norway are doing, and I wasn't able to finish the conversation. Right, I know you're excited. You want to hear about Norway? Okay. These guys basically said, okay, I'm going to open it up so that all of my minions here are able to execute a command on everybody else and get a list of all the other systems in the environment and just plop it into their host file. And they never deployed an internal DNS server. Okay? Because they're able to continually get real-time information about what's out there. Now, another cool thing about this is that, say we're running our config management routines down on this guy. We can easily say, okay, let's say this guy's a load balancer. Here's the classic example. Let's say this guy's a load balancer. He needs to be aware of everybody who's out there, all the web servers who are out there, to populate his configs, right? Well, during his config management run, he can send a command out, hey, run a command so that everybody who's supposed to be in my configs returns and tells me. Sends it back and he configures it, and those commands are made to run incredibly fast. And so it's still low overhead, and you're able to do real-time discovery about what's going on in your infrastructure. Okay? Now, let's start tying these concepts together. You know, I'm looking at this one and I'm thinking, this is a horrible presentation for people who don't know SALT. Just horrible. Because here I am saying, SALT's really easy, but look at the console of the space shuttle. This is one of the most complicated things that we do inside of SALT, okay? And actually, a lot of guys don't use it, but it's very powerful. So we've got the salt master here, and we've got all of these events and actions that are being fired relative to everything that's going on out there, okay? And let's say that an event happens or data is returned and we want to react to that data. Let's say that data prompts us to say, spin up more virtual machines in a cloud somewhere. Salt has tools that integrates it with all of the major public clouds. Yes, that includes DigitalOcean. I know they're like really popular right now. Everybody's excited about them. They're in there. So let's say you get an event that basically says our systems are overloaded. Spin up more VMs, bam, the reactor can do that dynamically. Let's say you get an event that says something horrible has happened in the data center and that poor bloke's going to be there all night. The reactor could logically order him a pizza. So it's a completely open-ended system, but we're able to process events as they come back in and react to them. Again, one of the cool things about this is that this is completely turned off by default. All of these capabilities get turned on when you just add a line to a config. As soon as you activate them, they turn themselves on. Otherwise, they're not using resources. They're not bothering your system at all. Okay? You know, you'd think I'd remember Control-Shift-P after doing that so many times. Now, that says minions, that's the bottom. Similarly, we just added the capability to also have high redundancy of the master. Historically, people have been doing the classic bit with a VIP, you know, and keep alive and all that stuff. Who here doesn't know what I just said? Wow, we have like 8 honest people in here. No, I know a lot of you guys know what that means. Okay, but now we have it built in so that you can have multiple active masters controlling an infrastructure. Sorry, guys that have been using it for a long time get more excited about that one. Now, this concept here, fine, is the concept of being able to build tiers. Now, as I've been mentioning and alluding to inside of Salt, how this works is, say we've got our Salt master for these different data centers or different groups of servers in a data center, or maybe you want to set it up one per rack. You know, however you dream, you want to set it up. Actually, a really good example is how universities usually have done this. So we're deployed in a number of universities. We're being used at Harvard. We're being used at Columbia. We're being used, I was just out at Clemson University a couple weeks ago talking to those guys, fantastic guys out there. And so they've got a bunch of departments, and each of their departments have their own salt master. And those salt masters subsequently have their own minions underneath it, and they've got these encapsulated units because it makes sense for their organization. Okay, well, we also have a system inside of Salt called the Syndic. Think syndicate, where you take one of these masters and you put a syndic on it that says, hey, I'm willing to accept commands from a higher level master. This allows them to say, sure, we've got all of these groups of systems spread out throughout the organization, but we're able to command all of them if we want to from a top level. Now, this also helps substantially with scale. So we get into a situation where we say maybe there's 500,000 servers in an organization, which, well, you guys are out here, you know that happens. Again, California. Okay. Some of these guys we talk to in the Midwest. So, I don't mean that. Some of you guys are freaking awesome. Who's watching this online? You're great guys. It's all for the crowd. Yeah.
Doesn't support having multiple masters at each of the levels in the hierarchy. So, yes, like you could have 3 masters here.
So have 3 masters up here,
Yep.
and 3 masters up here?
Yes.
Yes.
Excellent.
Yes, the Syndic system is made to be completely open-ended. So you can have multiple masters at multiple layers. You can have crazy topologies. So this master could have its own minions, and this master could have a master with its own minions if you really wanted to do something insane, because it's a transparent pass-through system. Yes?
Oh, sorry.
Yes. No, you won.
What do you do about conflicting requests? Like, do you have a global clock? How do you, two people want something different on two masters want something different on a minion?
Okay. Every request that gets processed through is tagged with a job ID, and those are guaranteed to be unique. And so those tags then go through and process individually. Now, let's say that you had two masters, and for some reason they both told the same system to set up, say, different network ports. No, we don't have anything that's checking for that. We do say to you, please you got to keep your masters in sync, and and we do have a number of tools that help you have that happen. Yes.
What about security and like spoof prevention?
Sorry, spoof prevention.
In other words, having somebody another machine be a nasty master and tries to ruin a system.
Okay.
Sorry, I'm QA. I think like that.
No, that's good. Okay. Now everything is authenticated and encrypted. The way that this works is that you've got all these minions out here, and they're not binding to any ports locally. They're all attaching to a higher level master. They're only going to attach to a higher level master if they've already accepted that master's keys. So the way that you could have a bad master is that they'd have to compromise those keys and then convince the minions, probably without touching them, to then attach to it. And yeah, we've got a number of systems in place to handle that. But basically at the end, if somebody steals your private key, the game's over anyway. But even then, they would need to either be intercepting existing TCP connections to make that happen, because they can't push out to those guys. They have to hook back in. Okay. That's actually one thing that we've had a lot of security teams come back and say that they really like about Salt, is that you can't just arbitrarily attack the minions because they don't have an open port to attack. Okay. I shouldn't say can't. There's always a way.
Is it UDP or TCP?
TCP. Yes, it's asynchronous and TCP.
That's different.
Yeah, I know. It's kind of cool how it works. It's all queuing, lots of threads down in C that we call with the C library.
0MQ, no?
Yeah, it's all 0MQ under the hood. Actually, speaking of 0MQ, we are in the process of exploring non-0MQ communication mediums. Because, what?
I was asking why.
Why? So I love 0MQ. I think it's fantastic, and we don't run into a whole lot of problems anymore. Yeah, we definitely did it first. And then they came out with 0MQ 3.2, and things have been a lot sunnier. Yeah.
So the command to the median, they are all independent, or could they have a case they are dependent to each other?
Sorry, so a command comes into a minion and they're dependent on...
So for every median, they are totally independent, or actually could I have some use case, a median would depend on another median's response for the next action?
Yes.
Can you repeat the question?
Yes. Sorry, I have been totally forgetting to repeat questions after I just talked to the guys and they told me and they reminded me. So the question is, and then, sorry, we kind of got derailed. And I'll come back to the question about why allow something other than 0MQ for transport. But the question is, can you have a minion can you have a minion command be dependent upon information gathered from another minion? Okay, the answer to that is heck yes. So that peer system that I put up on the front is one of the methods that you can use to do that. We've actually got a number of layers of those plausible methods. The peer system idea is that The minion itself can ask about that other system and then execute the command based on that data coming back. And so it's all based on live, hot data. Now, the next layer that we've got there is something called the salt mine. And the salt mine allows the master to passively gather data about its environment. So it's cached data, it's old data, and then let minions react to that information instead of reacting to live events. Or you can use an external database through Salt's returner system if you want to turn that on, which allows you to cache information about all the jobs that are being run in any arbitrary external database. And by any, I mean not, well, we don't out-of-the-box support all of them, but you know, MySQL and Postgres. Because have you guys ever written a feature for MySQL in a big project and then you just kind of hold your breath for a Postgres guy to get pissed off? They're great. What? Yeah. And then they come in and they're like, well, I gotta be trumped by this garbage. Okay, anyway. So yeah, MySQL, and then by default, since we have good MySQL support, there's great Postgres support. Because those, again, they're freaking awesome. And then support for guys like MongoDB and Redis and all those guys. Those NoSQL databases as well. Okay, and then it was why. Okay, so the original concept there was to allow Salt to execute without having to install minions. And this is one thing that I'm actively working on right now. It actually works in Git head right now. It's not in a version. I've got a slide that briefly discusses it later. But so you can use SSH as your communication medium to all your systems, and you never need to install anything on those target systems. So you don't actually have to set up a master and minions. The cool thing about that approach is that it makes experimenting with Salt even a little easier. And the nice thing there is that you're able to say, hey, you know, I'm starting up this light, small infrastructure, and I'm building it with Salt, but I'm using SSH because I can get it up and going a little quicker. But all the stuff that you're building is still going to work perfectly fine on Salt with ZeroMQ. The other reason why we're looking at it is just because we've got a couple of big companies that want to see the detachment from the COM layer, because they want to insert Salt into some of their existing communication frameworks to send commands, and so that it has its management systems in there. So, yeah, those are the reasons.
When minions want to get information, they always have to go through the master. Is that true? I know in the peering slide that's what it looked like.
Yes. Yes, they broker through the master. They're not doing cross-communication from minion to minion.
And the mines, they live?
The mine data lives on the master.
Okay.
Yes. So that's the choke point. All right. Any other questions about that craziness?
How does data sync between the mines of the masters and the multi-master system?
How does data sync between mines on the multi-master system? Yeah, I'll get you in a second, Chris. I see you now.
I want a demo, dude. A demo.
All right, fine. Fine, I'll give you a demo. Punk. Now, okay, oh, I know him. I can call him a punk. Sorry, how is data synced between the mines? When mine is executed on the systems, the minions themselves replicate that to the multiple masters. So they push it up to the individual masters. Okay? All right. So you want a demo? Okay, I will completely derail into a demo. If I can find a terminal here. There we go. Make it projector worthy. Does everybody read that? 10 points for anybody who knows who Fenrir is. Yeah! Who said that? Postgres for the win. Now, all right. So Salt is easy to set up. Now, it has a couple of external library dependencies. and it's packaged for all major Linux distributions. It also runs on Mac OS and Windows. Okay? And so you can download the Windows installer and next the Windows way. Okay? But we've also got a script called Salt Bootstrap that you're able to run that script, and it's going to go and add the right package repositories for that system. So it'll add the Ubuntu PPA, or it'll add enterprise packages. Sorry, extra packages for enterprise Linux if it's a RHEL system, and then automatically come in and download everything for you. But beyond installing it, which has been, again, very streamlined, all you have to do to start it up, actually, let me just double check that I, okay, good, nothing's running on here. All you have to do to start up the master is either run it with, obviously, the init script or the systemd call or the upstart call or, you know, blah, blah, blah. It used to just be sys5 init and BSD. Okay. Call salt master. If you pass -D, it says run it in daemon mode, so it does the double PID fork. You know, the double PID fork. Okay. And then the minions only need to know one piece of information for them to function, and that is where their master is. That's it. If you have multi-masters, then they need to know where their masters are. Okay. So we go to, that's right, the minions config file, and we're telling it that it's at localhost. Now, by default, the minion looks for a master with the DNS name of salt. So you just, you know, if you're in an internal network, plop that into your DNS, and you're done. Okay? Now, we've got a number of tools also, like Salt Cloud, that is used to bootstrap minions in cloud environments, and Salt Cloud will automatically load these values into the minions so that it's completely automated. So that it's really easy to just say, spin up me a bunch of Salt minions and tell them where the master is. Okay. So I've got a master running. I'll run this in debug mode so it'll be loud. Okay. We start it up and it says, hey, we're waiting for our key to be accepted on the master. Okay, no, you do not need root. By default, the way that you control the Salt Master is to just become root on the Salt Master, and then you have all power. But Salt has something called the external authentication and the client ACL systems. Those allow you to say that if somebody logs into the Salt Master as a user, then they have very limited rights as to what they can do. So it says this guy can now run these routines, but only on these systems. External auth is the same, but it doesn't rely on an existing Unix user. It allows you to use any external authentication medium. So they can, do it that way. Okay. But root gives you all power. All right. It must be coming up as localhost.local domain because of the operating system I'm running. Now, while I clean this up, I'll tell you a joke. How do you know if somebody's an Arch Linux user? They'll tell you. Okay. Yeah. So I'm running Arch Linux, which is probably why this happened. Okay. So I accept the key using salt key, really straightforward. We do actually have a mode that allows you to dangerously automatically accept any key that's given to you. It works really well for military bunkers. I think I mentioned that I did used to work for the U.S. intelligence community, and they did have demand for surprisingly highly insecure systems because their security was based on the barrel of a gun and not the network integrity. Okay. So now it should be in. Yep. All right. And so what I did here is I said, okay, we're going to run salt, and this is your basic communication out to a single system, and I'm going to run a function on that system that's in the salt library. Now, like I mentioned, salt comes with this big library of functions, okay? And it's self-documenting in a number of ways. Got to pipe this to less. And so we can do salt star sys.doc, and it's going to go out to all those systems, and it's going to return the documentation for the functions that are available on the systems which you are targeting. And as we go down this, we'll see we have things to manipulate Linux ACLs for files, which always happens to be on the top for obvious reasons. Managing the aliases file, archives. We have some ridiculously granular shell-out capabilities. Yes?
I'm going to take a guess that if you had multiple minions and one of them did not support one of the commands, it would then tell you which one is supported in that process.
If you've got multiple minions, then this particular command just merges them all together.
Yes, but if one of the minions didn't support that command, would it say inside that quote, it will just tell you which minions did?
Okay, if one of those minions doesn't support that, we've got another function that does that.
Oh,
Okay. So yes, that capability's in there. All right, so anyway, we go down and we've got a lot of things. The CP module is used to interact with Salt's built-in file server. I don't know, did I mention this? It's such a blur. Salt's got a built-in asynchronous queuing file server that runs on top of ZeroMQ that has been optimized for downloading files in parallel to tons of systems at the same time, which is why we can run concurrent configuration management runs on, well, back at the office we tested on 10,000 systems in parallel. So that we confirm that we can have 10,000 systems running config management at the same time, which is not the same as saying we can handle 10,000 systems. Okay, so anyway, lots of functions. Manipulate cron, work with daemon tools. There's that data backend I briefly talked about, a bunch of Django interaction, DNS mask, EX file management, Ruby gems. There was Git back there, manipulating virtual machine images, table stuff, key dot. Oh yeah, that's cool. Anyway, you can manipulate your keyboard configuration settings inside of Linux. Locate LVM. Yes, you can set up LVM. Don't be stupid. Okay. There's the mine, getting stuff out of the mine, mounts, networks, partition setup, Python group, pip. I know I'm going through this quick, but this is the function name you call, description. They all have examples.
Why recreate the command line?
Because all of these functions that you execute are convenience functions that always take that information and put it into a data structure that can be ingested and used by Salt. So all of these routines also make up the backbone for the entire configuration management setup, which is why we recreate the command line. And yeah, I wouldn't call it just recreating the command line as much as putting a bunch of convenience wrappers around that allow us to easily track exactly what's going on. Okay, anyway, oh, yes, I need to mention this one here. PKG is a great example of one of the really cool and somewhat magical things that Salt does. PKG stands for package. So you go to Linux systems and they've got packages and package managers. PKG is going to be automatically routed to the underlying system's package manager. So you can have a bunch of minions that are Red Hat and Slolaris and sorry, I couldn't keep a straight face. Okay. Red Hat, Ubuntu, Debian, Windows, whatever. Okay. And you can say pkg.list packages there, and it's going to go to the correct underlying package managers normalize the data between all of those package managers, and send it back to you in a completely predictable data set that you can work with, okay? Because this core concept, again, of just gathering data is really important. You know, and we've also got, there it is, package.install. I do know some guys who use Salt, and it's their way of not learning how to use package managers. But yeah, package.install is automatically going to convert down to the underlying package manager. Now we're going to see, where is it? Oh, is it not in this? Whatever. But yeah, oh, there it is. Install the past package add refresh equals true to install with a -sy, because that's the document that's being brought up for my minion because it's running Arch Linux, yes. Okay.
You're supposed to tell me that.
All right. So lots more things on packages. There you go. Postgres. Yeah, anyway, it keeps going. Yes, there's some Ruby stuff in there. If anybody knows Ruby better than me. Okay. Now, the next thing I'm going to start diving into, here we go, is the state system, which is what configuration management is inside of Salt. The state system is invoked through these remote execution commands. Okay? So you run a state dot, I've got all the wrong commands up there. You run one of these lower level commands. Okay. There we go. So you run this state.highstate command here to say, do your config management run. Yes? We wrote a sorry, the question was, these are all Unix-y commands. Thank you. Sorry. The question, oh. Sorry. There we go. Jeez, Postgres is bad 1,000. Windows Package Manager. The question is, these are all Unix-y. Do you have the same level of support for Windows? There are a few functionality components that we haven't covered in Windows that are covered in Linux. There are a few functionality components in Windows that don't apply to Linux. We have a package software deployment system that makes package management on Windows work in a similar way to Unix. So yes, we can deploy, monitor, and manage software on Windows a la the package system. Yeah, and same with file management and registry management and a lot of other Windowsy things that my Windows guy takes care of. Yes. Yeah, we've got support for Homebrew in there right now. Yeah. We haven't seen a lot of demand for Mac ports yet. No, I know. Okay. Any other questions that I can fail to repeat into the microphone? Excellent. All right. How am I doing on time? I got no clocks. I should have looked at my TARDIS when I pulled it out. What? It's 8:30. So when am I supposed to finish?
You can do whatever you want.
Oh. So I got to catch a BART before 11:30. Sorry, yeah.
If I could ask this, I do all of these things right now with Puppet or other tech functions.
Yeah, so the question was, what does Salt give you over other existing configuration management systems? The biggest answer to this is that Salt comes loaded with all of this orchestration and execution stuff as well. The next big thing is, like you said, it is very fast. Beyond that, it's all based on YAML and the configs, which I'll get into here in a second, for the configuration management system. It's ridiculously flexible as to what you can do there and very powerful, but it's also really easy to learn and set up and run with. actually one of the biggest problems that we've run into recently is that we're trying to build a repository of SALT formulas for the config management system, but the problem is that people are less than interested in contributing to them because they come and they say, well, but I don't want to download somebody else's because they're so easy to write. And we get this over and over and over and over again. It's getting kind of old. I'm like, well, just make it. Noobs like this stuff. Who cares if they're going to write their own in 2 weeks? We got to bootstrap people. But yeah, it's incredibly easy to use and very fast, and it's made to be very lightweight on your underlying infrastructure. And it's made to scale to ridiculous levels. Okay. So anyway, config management. Wow. KDE has betrayed me. like again. Okay. So config management inside of SALT is called states. Now, they're called states because the core idea behind them is that you use them to enforce the state of specific units of the system, okay? And then you bring these individual enforcements together to create configuration management. Okay, a couple of things that I should mention. There's a paw in the way. I've already talked about the fact that it's data-driven. Again, I'll give you some examples here in a second. By default, SALT is a declarative configuration management system. That means that you declare the state in which you want a system to be in, and then SALT goes out and makes sure that it is in that specific state. Okay. Some people would rather do this in an imperative fashion, which means that you list in order what you're going to be executing. It executes them, and then once it gets to a failure, it just stops. Okay? So SALT, by default, is declarative, but it has the capability to run in an imperative mode. Now, since it is all data-driven, under the hood, SALT comes with sane defaults. By default, you declare things in YAML. It works incredibly well. The vast majority of guys out there use YAML for everything. But SALT is language agnostic, meaning that you could write your own programming language on top of SALT, okay?
I don't know how many more slides you have, but probably budget Q&A as well.
Okay, so I'm going to start wrapping up here and do some really quick, I'm going to do a really quick example of config management because it's clear that I have talked too much. I know, it's an ongoing problem. My parents hate me for it. Okay, so something really simple here for the config management. This is installing and starting Apache, okay? We say Apache, it's a package, make sure it's installed. There's a service with Apache, make sure it's running. The name of the service is HTTPD, and make sure that package got installed before you turn it on.
So a lot of the juggling I do with Puppet is saying, oh, well, crap, CentOS wants to call it HTTPD in the package name, and Ubuntu wants to call it Apache. Are you abstracting that by just saying Apache? Do you have mappings of packages, or what do you do for how specific is it?
We've got a couple of options as to how to do that. Now, the default way is that all of these YAML files can be templated with your Python templating language of choice. The default's Jinja, but if you like something else, you can use something else. And inside that templating language, you have access to not only the grains on that system, which allows you to map it out and say, if this, then this, if this, then this, as one piece. But you also have access to all of those executions in those libraries. So you can gather data about the system that this is running on dynamically and have that modify the system, modify what's going on as well. I clearly don't have enough time to talk about Pillar, but Pillar is a system that would allow you to localize all of your package juggling in one place, and among many other things that it does, so that you can have one place where you just have like a template of, these are the packages I deploy, and this is what they are in Red Hat and Debian and all this stuff in one place, and then realize it in a very succinct way in the wild. So, yes. Okay. Now, there we go. So let me wrap up really quick. We have an event coming up. I just found out we solidified a spot in Paris too, which obviously doesn't apply. California. But we have an event coming up called the Great Salt Sprint. Alexi mentioned this. Thank you. The Great Salt Sprint, this is the second time we're doing it. The first time we did it, it was located in 2 places, at Cars.com's office down in LA and at the C7 data center in Salt Lake City. Now it's at the SaltStack office in Salt Lake City, because when we did the first one, we didn't have an office yet. But it's around the world. All of these locations are going to be coordinated over Google Hangouts. We're going to be talking about Salt development. We're going to have more pull requests than I can shake a stick at, because we love pull requests. Salt is one of the largest actively developed open source projects in the world right now. Last year, GitHub said we were the 8th largest developer community on GitHub. Thank you. Okay. But so we've got a lot of these locations, and if you go to sprint.saltstack.com, you can see where they're at. I mentioned we're trying to make more formulas in our big formulas repository. Seriously, take a look at the Salt code. If anybody wants to stick around, I'm more than happy to show them what Salt code looks like, because we didn't get that far. But extending Salt is really easy. And it's been made from the ground up to be really easy. So you don't need to learn a lot of internal intricacies to make it happen. In conclusion, I wish I could talk to you for 8 hours. but I can't. Because like some Yelp people probably need to go home. Okay, but no, in conclusion, Salt's awesome. It can do anything that a config management system needs to do. But yeah.
Come get a mic for questions. Anybody?
Great.
Just a quick question. How small can you go with this? In other words, could somebody use this for like their home network?
A lot of
Like 5 Windows boxes or something.
A lot of people use it for that. I wasn't able to talk about the, sorry, golly. How small can you go with it was the question. A lot of people use it for that, but yeah, you can go all the way down to just a couple of machines. We've got a lot of guys who roll out a bunch of states for just setting up a laptop. You don't need to actually set up a master and a minion to run Salt. You can just plop those files on a local system, and we've got a command called salt call that runs on the minion logically, and you can say run without ever accessing a master, and it all works.
So would it be smart enough like to push out a new version of Symantec to like 3 Windows boxes, or is that a little too complicated?
No, that should work just fine. Actually, we've got guys in the wild doing that. Yes. Yes.
Puppet has been frustrating for me. You're making a company. You obviously want money. How do you
I like money.
to balance that?
Okay. No, that's a serious concern. One of the biggest concerns that I have from the perspective of the company is that I don't want SaltStack to be a company that isn't continually trying to solve the problems of the people using the software. And I think that going open core, for instance, would substantially cripple what we're doing as a company. And I'm really excited that our business model is filling out and people are paying us for support. We do have an enterprise version of Salt, but it isn't a version that's got more features in it. The enterprise version of Salt is a long-term commercially supported version of Salt, and feature development and everything that's going on is still happening out in the open. And we're not closed sourcing our UI, for instance, that's under development. It's all just being tossed out there in the open initially. It's been exciting. We've learned that a lot of companies still are very interested in buying enterprise salt, even though we're not basically forcing them to do it by saying, well, the only way to get some feature is to pay us money.
Thank you.
Yes?
How easy is it to switch from Puppet to Salt?
The question is, how easy is it to switch from Puppet to Salt? Well, that depends on a lot of things. How are the politics at your organization? You know, in all honesty, that's hard to say because it differs depending on the person that's doing it. You do need to rewrite your config management in Salt. We don't have like a magic Puppet to Salt compiler. But the feedback that we've gotten, or rather some of my favorite quotes, is when a company comes back and says, we deployed Salt and it took us 2 weeks or a month to do what it took us to do in the other guy in a year. And we get that a lot. And the other things that we hear from people is they say, well, it took me n number of days or weeks to set up one of the other guys, and it took me 10 minutes and Salt was working. So it's something that you'll have to try on your own. I'm not going to make any claim that it's going to be exactly 10 times easy or any garbage like that. But the feedback that we generally get is that people don't find it difficult to switch over. Yes? Oh, no, sorry, what was your question? Okay, is anyone managing switches with Salt? So we're actually in the process, we have a number of partnerships with switch manufacturers, and we're in the process of allowing them to deploy the Salt minion directly on their switches. And that's something that's under heavy development. We do have a few guys who are managing switches using Salt with indirection and then calling them remotely, yes. But that's one of our current heavy development components. Yes, over here.
How do you go about testing?
How do we go about testing? Okay, so the Salt code base has integration tests and unit tests built into it. The integration tests can be run on your box. You can download it and just execute them. They're not going to hurt your box unless you pass -- destructive into them, which is how we test. We use this test suite to spin up virtual machines for platforms that we target and then execute those. Then execute the integration tests on those systems. Does that answer your question? Okay. Yes?
What do you remedy?
So the question was, what ZeroMQ errors did we see before and what did 3.2 remedy? The ZeroMQ errors that we primarily saw before had to do, one, with the fact that we were running a lot of ZeroMQ, particularly on the master, and sometimes the sockets would conflict with each other where they shouldn't. We were properly creating them and isolating them, but they would still have, sometimes their queues would conflict. And I see, I'll get you. And so that was one problem that we don't see anymore with 3.2. The big problem that we saw with 3.2 is that it would drop connections. Or sorry, before 3.2, is that it would drop connections. And 3.2 solves that. So yeah, it used to be that we'd have a minion connected to a master, and if it was over a network that had so much as a hiccup in it, then bam, we'd lose connection, and we'd have what we called minion droppings. And yeah, ZeroMQ 3.2 clearly takes care of that. But that was a headache for a long time. Yes?
Yeah, I actually have 2 questions.
Not yet. So the only system where we've got minions writing to multiple masters is on the mine. And that's actually, I mean, that's pretty much the only time when a minion reports data back directly to a master in that fashion. Otherwise, the minion is reporting specifically to the master that called it. But yeah, there's a number of components like that that we're still building in. The high availability in the master is very, very new. And there's still some things that we're solving there.
My
No, the state system can do that very quickly. Because one of the things that we do inside of SALT is that it's really easy to compartmentalize what you're executing. So you can easily say, okay, we've got a new system in the environment, and when it's done spinning itself up, it can either, well, there's a number of ways you can do this. It can either be able to send something through the peer system when it's done to say, update everybody else's firewalls. It'll only run that specific state routine, and then they're up in line, or you can build it in with a reactor. So there are ways inside of SALT to compartmentalize it and slim it down so you're only executing exactly what you need to execute on those systems to make it as quick as possible. Does that answer your question? Thank you. Yes?
Yeah, just in your concept.
So the question is, what is the tipping point between a no client installed or SSH-based system and when SALT starts becoming more highly effective or faster? It really depends on how you're using those SSH-based systems. We've had guys come back to us and say that they prefer SALT because on their 10 systems it's substantially faster. We've had, one of my favorite quotes is actually from Harvard University. They showed up, they put this on Google Plus a long time ago, so heavens I can't find it anymore. It's even there. Well, you know how these work. And they were managing 1,800 systems. And they came back to us and said, okay, it takes 5 seconds to execute a command against all of these systems with SALT. And that the SSH-based tool they were using in the past was taking them 15 minutes. So it's substantially faster. Another one of the arguments that people come back with, and they say, well, we don't need this level of parallelization or this level of performance when we're executing on many systems because we just don't see people doing it that often. Well, we see people doing it all the time because they can. And so really at the end of the day, it enables you to do more with the underlying system. And admittedly, that's part of the reason why we're developing an SSH-based system is so that, because it does make sense in scenarios with smaller numbers of servers. Who wins? Okay.
I have a ton of chef scripts with maybe example and YAML and SLS.
So I think that the question is that we need to make sure that we don't execute something until we're sure something else is finished successfully.
It's kind of like a way to do a custom, a custom bash or shell script based state.
Ah.
That wouldn't involve having to write a new command line entry. But in other words, can you do it in YAML or do you have to write a command line entry to achieve that?
I'm still not entirely sure I'm perfectly following you, but you can execute, you can inside of the YAML call to execute an external script,
right.
And then respond to what that script returns. You can execute an external script in such a way that that script inherently gives you back the state information.
In Chef, it's called an only if, so you
only
execute the script.
Just an only if? Oh, yeah, we've got that. You just say only if and then script location.
So you can just put bash right in the YAML.
Yeah.
Oh, cool.
Yeah. That was easier.
The model for Puppet is sort of like from the master side.
It's driven from wherever you want to drive it from. So SALT comes with a built-in scheduler. And so you can tell the minions that they're going to do it that way, in which they're checking in every n number of minutes if you want to.
And the minions know to do what? Like, what instructs what the minions should be doing?
Oh, you
like
tell them.
Manifest, yeah.
Yeah, you tell them to run a high state, and the high state goes to the master and says, "Tell me what I'm supposed to run."
Okay. Ordering was the next question because that's occasionally becomes a problem, and you need to do something before you do other things.
Yep.
You do it with really well-defined requirements, but it's cheaper if you can just say, phase 1, phase 2, phase 3. Do you have something like that?
Okay, so the question was ordering. Can we order the execution of the states? Yes, and to a lot, and you've got a lot of options around that. So every time you run states in SALT, they will always execute in the same order. And we've been very, I mean, I'm not going to go into the execution environment algorithm right now, but they always run in the same order. The SALT has a concept of evaluation order and runtime order. Evaluation order is the order in which it goes through and it checks them. And then it has what's called requisites, which are similar to the require in Puppet from where you're coming from. But we've got a couple of these requisites that can do some pretty tricky things. But they basically say, yeah, we're going to make sure that we're only going to run after this other guy runs. This other guy's only ever going to run once. And then we're going to run based on the information that we get back from that guy. And we've also got like the prereq requisite that allows you to say, I'm only going to run this routine if this guy is going to run in the future and change something. So there's a lot of constructs around that. And then in our PyDSL, you can flip on a mode to say run imperative, which means that it'll just run in the order in which they're defined in the file. Yes?
Can you talk about SALT monitoring, commands for monitoring?
Can I talk about SALT monitoring and commands for monitoring? Yes, we've got a number of guys out there that are using SALT for monitoring. We're working on some more monitoring subsystems inside of SALT that take advantage of the state system so that they tie back into the reactor a little more smoothly. Actually, I'm trying to remember, somebody just came out with a dashboard that basically does monitoring inside of SALT. And so it's going out and executing specific SALT routines and then bringing them back and displaying them on a dashboard. So I certainly wouldn't say that we're up against Xenos right now, but there are a lot of monitoring capabilities in there today. Is that what you're looking for? Okay.
All right, let's have last question.
So you're just saying that the management is inside a foreign network?
Yeah.
Okay. How SALT is set up is that again, the minions just need to be able to get to the master, and the master doesn't need to be able to get to the minions. And so if you're able to create any way to tunnel out to a master from an external network, then yeah, it should work just fine. Yeah, that's enough.
That'll get through NATS just fine.
Oh yeah, oh yeah. Yeah, we don't care about gnats.
Well, I know we can be here till 11 o'clock, but that's not going to be very good.
Right.
Thank you so much, Tom, for